Hello friends. Let's in the last lecture we have seen that how we can convert from NFA to DFA. Now in this lecture we will learn and that how we can convert from NFA with epsilon move to NFA without epsilon move. See, before that, first we need to understand that what is epsilon move. See, epsilon move is something like, say for example, in this case there is a epsilon transition from A to B. Okay, this means that from A to B we don't need any symbol to going from A to B. So without any input symbol we can make transition from A to B. So this epsilon means that there's a null string. Okay, so if there is a null string in the input in this machine, so we can make the transition from this machine from this state to this state. Okay, so that is what epsilon move. Now our task is that how we can remove this epsilon transition. Okay, so that is our task, and that how we can remove this epsilon move and convert this in a without epsilon move NFA. Okay, how we can convert, so there are some steps that we need to follow. So in the first step, what we need to do is, first you need to draw the initial state and the final stage as it is that in the case of this machine. Okay, so that is that is our first step, that make initial state and then make final state. Okay, and the number of states are same, so there is no change of number of states. जितनी स्टेट हमारे पास यहाँ पर हैं उतनी ही स्टेट हमारे पास कितनी होंगी यहाँ पर होंगी, है ना. ओके, एंड जो इनिशियल स्टेट हमारी यहाँ पर है वही इनिशियल स्टेट यहाँ पर होगी, जो फाइनल स्टेट यहाँ पर है वही फाइनल स्टेट हमारी यहाँ पर होगी. ओके, सो दैट इज फर्स्ट स्टेप. Now our next step is the transitions. Okay, so now make the transition in this machine. See, we have input symbols that is 0 and 1. Okay, so हमें सभी जो दोनों इनपुट सिंबल हैं उन दोनों के बारे में दोनों के लिए हमें ट्रांजिशन करने होंगे. सो नाउ स्टार्ट्स फ्रॉम द 0. सी, from state A making a 0 transition. Okay, so there is a self loop of 0 from A, so we made this 0. Okay, now what difference is that after making 0 transition we can also move from A to B. So that means with the 0 transition we can have A as well as we can also have a transition from A to B. Okay, why? Because in this case we can make 0 transition and then epsilon. That means the case may be such like 0 and epsilon. So we can write 0 as what? 0 and epsilon, or also as epsilon dot 0 dot epsilon. See, epsilon is a null string, so that doesn't make any difference in the input symbol or input string. So for this, these two are equivalent, so that means 0 and then epsilon. So that means for the 0 transition हम A पर भी कर सकते हैं and then from A to B also. Okay, now we have seen what? 0 transition. Now for the 1. Okay, what about the 1 transition? See, if we write 1 as epsilon dot 1, or we can also write epsilon dot 1 dot epsilon, these all cases are equal, so there is no difference. We can append this epsilon before this one or after this one, so that doesn't make any difference. So that means epsilon and 1. So from A we can also have a transition for 1 from A to B. Okay, there is no self loop because in this case we cannot stay on the same state from A. We have to move from A to B for the transition 1, that is epsilon and 1. So we can make transition from A to B for the 1. So that is 0 and 1. Okay, now we have done both the transitions, that is 0 and 1. Now at this stage B. Okay, from state B, if we see in this diagram, so there is no transition for the 0. So in this case also we cannot make any transition, because in any case, like either we write 0 epsilon or epsilon 0, in any case we cannot make transition from the state B. Okay, so we transition for the B, it is not possible from the state B, but from the state B, for the symbol 1, it is clearly seen that there is a self loop of 1. So we made this. Now what about the rest of the third case? See, if we look at this and this, that also doesn't make any difference in this machine, so there is no more transition for the 1. So that is our converted NFA without the epsilon. Okay, so that is how we convert from NFA with epsilon to NFA without epsilon. Okay, see, similarly we have also a second example, that is this. So again we will follow the same steps. Okay, see, one more step is in this state is, if see if we find epsilon closure of A, that is your initial state. If you find this epsilon closure, and if in this closure, if you will have all these states, like in this case A and B, so if such case happens, then you need to make initial state as the final state. Okay, so let's find the epsilon closure of this A. सो एप्सिलॉन क्लोजर ए, एप्सिलॉन क्लोजर का मतलब ये है कि एप्सिलॉन के ट्रांजिशन फ्रॉम द स्टेट ए अगर हम करते हैं तो हमारे पास कौन कौन सी स्टेट यहाँ पर आएंगी. सो एप्सिलॉन ट्रांजिशन अगर हम यहाँ पे करते हैं, दैट इज द फर्स्ट ट्रांजिशन. विदाउट डूइंग एनी ट्रांजिशन वी विल ऑलवेज बी इन द स्टेट ए. सो एप्सिलॉन क्लोजर ऑफ एनी स्टेट विल ऑलवेज वी हैव द सेम स्टेट, दैट इज ए. तो अगर हम ए स्टेट का एप्सिलॉन क्लोजर निकाल रहे हैं, तो ए विल ऑलवेज बी in the closure of A. Okay, so it is clearly seen in this case that from A to B there is a epsilon transition. So that is also be possible that in this epsilon closure of A we can have both these states. Okay, so if this happens, then we need to make this initial state as an final state, or in another word we can say that if you can reach from initial state to final state with the epsilon transition, then always make initial state as a final state. Okay, and accept that there how many number of final state in this case? Only one. And in this converted NFA we can also have same number of final state, except that if you can reach from initial state to final state from the epsilon transition, then only one more final state in this converted NFA. And that is very much very much important point, that to count in this converted NFA. Okay, so let's convert this machine also. See, write all the state as it is, that we have here A, B and C. Initial state as an initial state and final state as an final state. Okay, the first step. Now second step is making the transition. So let's make a transition from state A. So from state A, see, similarly we can also write here 0 0 epsilon 0 epsilon 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 0 epsilon epsilon. See, such things doesn't make any difference. See, all these cases are equal, so there is no difference. So in first case, if we make transition for 0 from state A, so there is a self loop, so we will make self loop here. Okay, now if we see this case, that means after making 0 transition you can also move from A to B. So that means you can also make a transition from A to Z with 0. And if you see the third case, that means 0 epsilon epsilon, that means from A to C you can also make transition for 0. सो व्हाट द मीन ऑफ दिस दैट कि आप 0 का ट्रांजिशन करने के बाद ए से बी पर भी जा सकते हैं एंड ए से सी तक भी जा सकते हैं. ओके, सो दैट मीन्स आपने क्या किया, ए से आप 0 का ट्रांजिशन ए पर भी कर सकते हैं, ए से 0 का ट्रांजिशन बी पर भी कर सकते हैं, ए से 0 का ट्रांजिशन सी पर भी कर सकते हैं. ओके, सो दिस इज अ ट्रांजिशन फॉर 0. अगेन इट इन दिस केस ऑल्सो वी हैव 1 2 एंड सो इनपुट सिम्बल्स कौन कौन से हमारे पास 0 1 एंड 2. सो 0 का ट्रांजिशन हम कर चुके हैं. नाउ वी विल सी द ट्रांजिशन फॉर 1. ओके, in this case, like again we will write like 1 dot epsilon epsilon 1 epsilon epsilon 1 epsilon epsilon. See, there are so many cases, and but all these cases are equal. Okay, if we say in this case, so there is no transition from A to any other state, directly 1. But if we see this, there also there is no transition, that is there is no one transition directly. But if we see this, that is epsilon 1. Okay, epsilon 1, so epsilon and 1. So that in this case हम A से B पर ट्रांजिशन कर सकते हैं किसका, 1 का. Okay, so after doing epsilon transition we can make the one transition for the 1, and we can stay in this case, in this state. But this case is also happen that epsilon 1 and epsilon, that means from A to C you can also make a transition for 1, है ना. तो आप A से B पर भी 1 का ट्रांजिशन कर सकते हैं और A से C पर भी 1 का ट्रांजिशन कर सकते हैं. ओके, सो 1 is also complete. Now we will see the third case, that is 2. See, 2 epsilon or epsilon 2 and epsilon 2. So such or again all these cases are same. So see, epsilon and 2, this case will not happen, this case also will not be happen, and but this case is also not happen in this case, but this will be true. But all these cases are equal. So इसका मतलब क्या है कि हम A से C तक जो है 2 का ट्रांजिशन भी कर पा रहे हैं. सो दैट मीन्स फ्रॉम A to C we will also have transition for 2. Okay, now we have completed all the transition for input symbols. Now switching to state B. Okay, now from state B, अगर हम B से देखें, so there is no transition for 0. So 0 0 epsilon epsilon 0 epsilon 0 epsilon, all these cases will not be happen from the state B to C, and there is no transition from B to A. So in this case also it is not happen. Now looking for 1, that is 1 epsilon 1 epsilon 1 epsilon 1 epsilon. If we see the first case, that means it is possible because we have a self loop. Okay, now if we will see the this case, we will not have first epsilon and then 1. Okay, and this also will not be happened. But if you see this, that means 1 and epsilon, that means that happens, that is possible. So that means आप B से C पर किसका ट्रांजिशन कर सकते हैं, 1 का ट्रांजिशन कर सकते हैं. ओके, सो these are all possible cases. Now we look at the third symbol, that is 2. So 2 epsilon 2 2 epsilon epsilon to epsilon. See, if you will see the first case, so there is no direct transition from B for the symbol 2, and if you look at the second case, so epsilon and 2, so this case happens, this case is possible. So from B to C, so there is a possible that we can make a transition for symbol 2. Now this is a possible, but this is not possible. And if you will see this, so this will not be possible because there is no direct transition for 2 from B to C, and again this will also not be possible. So these are the transition from B to C. Okay, so this is also complete. Now look at the third state. See, in this third case, 0 and 1. See, in this third case, from the state C, there is no direct transition or any other transition for 0 and 1, either with epsilon or without epsilon. So there is no transition for 0 and 1, but there is a transition for 2. Okay, so we will see this 2, and there is no any other transition in this state. So this is our whole 0, 1 and 2 transition from each and every state. And now last step is that finding the epsilon closure of A. See, epsilon closure अगर A हम निकालते हैं तो that is A, B and C. See, directly we can see here that with the epsilon transition you can reach from state A to state C. From state A to C. So if you have all these states in the epsilon closure of initial state, then make initial state as an final state. Okay, so other than the number of state in the original case, we can have only one final state extra. Okay, if this case happens, that is epsilon closure of initial states contain all the states, which also means that if you can reach from initial state to final state with the epsilon transition alone. Okay, so in such case you can make initial state as an final state, and there is no need to make any other state as an final state. So this is your complete NFA. Okay. So that is how we can convert from NFA with epsilon move to NFA without epsilon move. So both are the NFAs, but in this case we have epsilon transition, but here we do not have any other epsilon transition. Okay, and in next lecture we will see that how we can convert NFA with epsilon move to directly DFA. Okay.